Okay, I'm going to work the first one. Of course, you've been asked to do partial fraction decompositions of these three expressions. Okay, this first expression is going to equal a over x minus 5 plus b over x plus 3. Writing this out completely, which is what I prefer you do, because sometimes you need to, instead of taking shortcuts, and the shortcuts are also valid when they work. But in general, you're going to put this side over common denominator. Because the denominator here needs to match the denominator here. So we can set the numerators equal. There we have it. So we get up with x plus 2 over x minus 5 times x plus 3 equal a times x plus 3 plus b times x minus 5 over x minus 5 times x plus 3. So there's an intermediate step, and I don't recommend that you skip that intermediate step. But you get a times x plus 3 here over x minus 5 times x plus 3, and b times x minus 5, and that's over x plus 3 times x minus 5, which is the same as x minus 5 over x plus 3. So now you can add the numerators. If you're not doing that step, you're not reinforcing the idea of how you add fractions, okay? Now, you might know perfectly well, you probably do. I don't recommend at this stage that you actually skip that step. You want to really have that idea reinforced because it's very important. In any case, that's good enough. So now the numerator equals numerator. So we have this equation. That tells us then and again, there's a step between here and here. You review previous videos, review whatever you need to in order that you understand how to rearrange this. But you just expand this and then put your x terms together and factor out the x. Right, so this is what we get, just a little rearrangement here. And this has to be the case for all x, all values of x. Okay, well, if it's true for all x, then a plus b, which is the coefficient of x, has to equal the coefficient of x here. A plus b has to equal 1. No matter what x is, a plus b is going to have to equal 1. And (3a minus 5b) has to equal 2. Now you have a set of simultaneous equations. You can solve for a and b. 5 times the first equation gives us 5a plus 5b equals 5. And the second equation is just 3a minus 5b equals 2. And now we can add the two equations and we get 8a equals 7. So a equals 7/8. And plug that into the first equation, which then tells us that 7/8 plus b equals 1. And do the arithmetic and to find that b equals 1/8. Now we take these two solutions up here. And we get these complex fractions. Okay. And of course, this fraction is just 7/8 times 1 over x minus 5. And this is just 1/8, the numerator, times the reciprocal of your denominator. This could be written this way. And there's a partial fraction decomposition. Okay. So what are we going to do with the second one? What are we going to do with the third one? If you got those worked out, let's try this one. Okay, I'm quickly going to just write out one step of this equation because it comes out very much like this one. It'll be 1, you just factor the denominator, x plus 2 times x plus 3. So that's going to be a over x plus 2 plus b over x plus 3, etc. And here's what you've got, and then you just do the same thing we did over here, but with the different numbers. Okay, so the procedure on this problem is the same once you factored it. The point then is that sometimes you got to factor your denominator. Okay. Now on x over x minus 3 squared, let's see. Going to be a over x minus 3 plus b over x minus 3 squared. Now that's the rule when you have a square. Okay. So that's that's it. If you do that and follow up, you get x over x minus 3 quantity squared equals a over x minus 3 multiplied by x minus 3 over x minus 3, which will give you the x minus 3 squared in the denominator. And this one already has x minus 3 squared, so you don't have to do anything to it. So now you can write x over x minus 3 squared equals a times x minus 3 plus b over quantity x minus 3 squared. Since in this case, I haven't written out this intermediate step as you should, but you've got an x minus 3 squared in the denominator here. And you have it here. So x equals a times x minus 3 plus b. Or x equals ax minus 3a plus b. Now we've got it as a multiple of x and just a plain old number. The multiple of x has to have the same coefficient on both sides. So a has to be 1. So you've already got your solution for a. It's the only thing with the x. And negative 3a plus b has to be 0 because you don't have a number over here. Well, those equations are really easy to solve. A equals 1, so you're going to plug 1 in here. You're going to get negative 3 plus b equals 0, so b equals 3, right? So your decomposition, don't have anything below to write it. I'll write it here. If a over x minus 3, that's going to be 1 over x minus 3. Plus b over x minus 3 squared, b is 3. There's your partial fraction decomposition in this one. Now, see what you can do with this one. That's about as complicated as they get. Well, they can get much more complicated. You're not going to get anything any more complicated than this in the exam. Okay.
It's an actress, isn't it?
Okay. This equals this doesn't factor because if you set it equal to 0, you're not going to get a solution. If it factors, then you're going to get a solution. So the thing equals 0. Each factor would be equal to 0. You always get zeros. If the quadratic formula doesn't give you zeros, it ain't going to factor. Okay, it just doesn't factor. So this doesn't factor, and we go ahead and write it in. And now this does factor. It's pretty straightforward factor. It factors into x minus 3 times x plus 2. We can check that by multiplying that. Negative 3 times 2 is 6. Negative 3 times x and 2 times x gives you negative x, and x times x gives you x squared. So there we have it. Okay, now what do we do with this? Okay, well, we've got over x over x squared plus x plus 4 x minus 3 times x minus 2 is then equal x plus b plus sign in there over x squared plus x plus 4. Let's look at one. Let's make sure it looks like 4. Because when you have an irreducible quadratic for every one, you're going to have an expression like this. You're going to have an x and a number. Okay? One way of saying it is the degree of this has to be 1 less than the degree of this. This is degree 2, and this is degree 1. Okay, then it'll be c over x minus 3 plus b over x minus 2. Now, what do we have to do? Well, we're going to want to express this sum as a single numerator over denominator, where the denominator equals the denominator here, because then we can set the numerators equal. So we get x over, just a little writing these out, but we're going to leave with it. X squared plus x plus 4 times x minus 3 times x plus 2 plus 2 plus 2. Next, it'll be like me and copy things down wrong. Okay, so what are you going to do about this first fraction? Well, you got to get this denominator, and you're missing the x minus 3 and the x plus 2. So your denominator here has to have x minus 3 and x plus 2. And of course, now, since you're multiplying the appropriate term, or the term that appears here, by something that equals 1, your numerator is going to have to equal same as your denominator. And then we got c over x minus 3. And we're going to multiply that by everything that we don't have in the denominator that we need to get this denominator, which means we're going to multiply by x squared plus x plus 4 times x plus 2 over same thing. So now we have the entire denominator that we need, and then we're out of room, so I have to write this here. So it's going to be d over x plus 2 multiplied by x squared plus x plus 4 times x minus 3 over x squared plus x plus 4 times x minus 3. Well, this then equals it started a little lower. This plus this, and then plus this product, d times x squared plus x plus 4 times 3. All this over our denominator, our common denominator. And that's of course got to be equal to x over x squared plus x plus 4. Our original denominator, I'm not going to give it all to you. Okay, there it is. So now our numerators are going to be equal. So x here equals all this. And I've just copied down this numerator, so now we can begin to operate on it. Well, I'm going to multiply these things out. It's going to take a couple of steps. X minus 3 times x plus 2 is x squared minus x minus 6. So now I'm going to be able to multiply this out because I can multiply the ax by the x squared by the negative x by the negative 6 and then the b times every one of these. Going to get a mess. I'm going to have to kind of tame it, but we'll be able to do it. Okay, so we have that. And now I'm going to go ahead and multiply this out. Okay. The x squared multiplies the x plus 2. So I've got x squared times x plus 2 plus x times x plus 2 and then plus the 4. And then I'm going to have d times x squared times x minus 3 plus x times x minus 3 plus 4 times x minus 3. So it's not difficult if you think distributive law, but there are a lot of steps, so your chances of getting it right are about the same as mine, pretty low. Okay. Still, we want to do the steps and hope that we can get it right. Okay, we're a little behind on this step, but we have to multiply this out. We'll catch up in a minute. So it's ax times this plus b times this. Now I can multiply these out. X squared times x is x cubed. And then we've got 2x squared. I almost wrote 2x. So I blew my first chance to mess it up. Okay, but I'll find a way. Okay, then it's going to be x times x plus 2. X times x is x squared. X times 2 is 2x. Now we've got 4 times x plus 2. Well, that gives us 4x plus 8 plus d times x cubed minus 3x squared plus x squared minus 3x plus 4x minus 12. Well, that's getting a lot easier. Okay. Now we multiply this out. Now I'm going to shortcut just a little bit. I've only got one x cubed term. X times x squared gives us x cubed, right? So that's going to give us a x cubed because there's no x cubed on this. And then it's going to give us a negative ax squared. Ax times negative x is negative ax squared. And b times x is negative bx. Sorry, b times x squared is bx squared. So we have a negative ax squared and a bx squared. That gives us you know what? There's not much point in collecting these terms there. So I'm just going to write it down. I'm going to shortcut it. It's ax cubed minus ax squared minus 6ax plus bx squared minus bx minus 6b. Then we're going to have cx cubed plus 2cx squared plus cx squared plus 2cx plus 4cx plus 8c. And that takes care of all this. And we get dx cubed minus 3dx squared plus dx squared minus 3dx plus 4dx minus 12. Well, that's pretty simple, isn't it? Well, that's a mess. So now I'm going to look for my x cubed terms. I've got one here, I've got one here, and I've got one here. So I get x equals a plus c plus d x cubed. Of course, I already know that we don't have an x cubed over here. So I know that a plus c plus d is going to equal 0, right? Okay. Then what x squared terms do I have? Well, these are my x cubed terms. My x squared terms, I've got a bx squared and a 2cx squared and a cx squared. Uh-oh. Didn't have an x. Yeah, okay, it's an x squared. And over here, I've got a x squared here and an x squared here, right? So it looks like I've got a 2cx squared and a cx squared, which is 3cx. And I'm going to write that as c times. And I'm going to write that as 3c for my x squared. Of course, I've got my bx squared here that I should have written down first, but I didn't. So we'll write it down now. And then minus 3dx squared plus dx squared is just minus 2d x squared. And then I'll write out the x squared here. So now my x squared terms, if I've done this correctly, all match. And then it's my x terms. Now, of course, we don't have any x squareds over here, so all this is going to be 0. We do have x here, so whatever ends up in front of x has to equal 1. But let's go ahead and just write down what we have in front of x. Uh-oh. I missed one, didn't I? I've got a negative AX squared here. Okay. We have to- I'm gonna rewrite this whole. Okay. Got a negative A on it, plus a B on it. And then over here, I have my 2C and my C x squared, which is 3C x squared. And then I've got negative 3D and D, which is negative 2D. That's all my x squared terms. Now, if I'd have been totally present in mind when I did this, I'd have realized that every one of these products is going to have two x squared terms. And then there's a certain symmetry involved that I won't explain, but I'm going to be looking for two x terms on each, resulting from each of these three expressions. So I've got a negative 6a and a negative b. Then I've got a 2c and a 4c and a negative 3d and a 4d. So I've got plus what? Negative 6a, negative b, a 2c, and sorry, it's a 6c, 2c and a 4c makes a 6c, and a negative 3d and a 4d gives us plus d x. And then all I've got left is my terms that don't have x's. So there's one here. That's, of course, the terms that don't have any other lines on them. Should be negative 12 deletion 3 times negative 12. So here, here, and here. So this will be plus negative 6b plus hc minus 12d. Okay, so what does this give us? It gives us 4 simultaneous equations. This has to equal 0 because there's no x cubed over here. This has to equal 0 because there's no x squared. This has to equal 1 because there's 1x. And this has to equal 0 because there's no constant. I need to think about volume control sometimes. As long as it isn't music, I can kind of live with it. It's music, there's always a danger I'll start to dance, and that's a terrible thing. Okay. Now I'm kind of out of room here. I'm gonna, well, where is it? That's something I can use. Hang on. There it is. You know, I've got a note here to my physics class because there's something they should have done but didn't. I'm going to keep that note so I can make notes so I can naggle about it again tomorrow. All right. So now what do we have? We got four simultaneous equations. We got A plus C plus D. Well, that must be A plus C plus D, leaving room for B's below here. A plus C plus D equals 0 because of no x cubed. Negative A plus B plus 3C minus 2D equals 0. Negative 6A minus B plus 6C plus D. I said that, I'm not going to remember, minus B plus 6C plus D equals 0. Equals 1, sorry, because that's our coefficient of x, which is going to equal the coefficient of x here. And then negative 6b plus 8c minus 12d equals 0. We see that it's going to be really easy to eliminate d. Just add multiples of the first equation to the second, third, and fourth. Our d's go away, leaving us with three equations with a, b, and c. Now those equations are going to be pretty easy to solve for b. Because whatever we have left after we subtract a multiple of this or add a multiple of this isn't going to affect the b because there's no b here. So the b's are going to be easy to eliminate. Now we're down to a system of two equations. And that becomes easy, okay? So I'm not going to do that for you. But after you leave, I might go ahead and add it to the video, okay? We're out of time. I probably will go ahead and add that. It shouldn't be too difficult. Doesn't mean it's going to be right, but you'll see the process. I'm sure I messed up some number somewhere. And before I do that, before you run off, for Thursday, which is our last class, remember this thing I handed out? 104 problems. Everybody got it? We've got a couple of extras if you need one. And if I run out of extras, you can email me. I can email you a copy, okay? But I want you to pick the 10 problems you would most like to see me work through in our final class, because that's what I'm going to do. Doesn't mean I'm going to get all 10 of them. If everybody shows up, that's 50 problems. That's too many to work, but I can at least comment on many of them. So I'm going to go down your priority list, put them in list of priority, just a number of the problem. And number 7 is your first choice, and number 3 is your second choice, right? Bring that to class, because that's going to be the foundation of what we do in that last class. Then if possible, spend a little more time making videos.
Can I have it?
Okay, let me make sure I can. I'm sure I've got plenty of copies. Anybody else need one? You got one?
I'll take one.
Sorry?
I said I'll take one.
Okay, everybody did a good job of staying awake through that whole process. Good job of taking it. We have these simultaneous equations. We can solve these. It isn't that difficult. Okay, so we do. Two times the first equation, that looks like a big nav D or something, plus the second. What's that give us? That's 2A plus 2C plus 2D equals 0, added to negative a plus b plus 3c minus 2d equals 0, giving us the equation 2a and negative a is a. We get a b and no b. 5c equals 0. So now we've got one equation with just the unknowns a, b, and c. So I can write that down here. A plus b plus 5c equals 0. And then we do the third equation minus the first. That's going to be negative 6a minus b plus 6c plus d equals 0. And minus the first would be a negative a and a negative c and a negative d still equal to not still equal to 0. Yeah, this is equal to 0. This is equal to 1. This is the equation that has a 1 on the right hand side. So, well, careless there. I blew another opportunity to mess it up. I'm sure I've taken advantage of others. Okay, so we have negative 7a minus b plus 5c equals 1. We can write that down. We have negative 7a minus b plus 5c equals 1. Now all we need is one more equation in a, b, and c, and we have a system of 3 equations that we can solve. Well, I got to eliminate d, but I chose to eliminate d because I have a single d up here. Could have eliminated c, or could have eliminated a. But except for the last equation, d has smaller numbers, so that's what I chose. Now, I don't have room to write out the addition. I'm just going to say the fourth equation plus 12 times the first equation. And I'm going to do it by pointing. You're going to have a 12b because you got 12 times the first equation. That's going to add to the negative 12b. It's going to give you 0. So you don't have a d. You better not, because you want the 3 equations over here to have the same 3 unknowns. Okay, so that gets rid of d. Now remember again, we do 12 times the first equation and add it to the fourth. That's going to give us a 12c and an 8c. Well, that's going to give us 20c. And then we're going to have a 12a. But we don't have an a down here. We just got a b. And I should put that negative 6b here so I notice what it was. Okay. We don't have a b up here. Well, let's do b. We don't have a b up here, so 12 times b is just going to give us still nothing. We're going to have the negative 6b from the fourth equation since we're adding the 2. So we get negative 6b and then we're going to have 12a. We don't have an a down here, so we're going to have 12a. Okay, so there's a third equation. Now you can write it out in the same detail I did. But again, I didn't really have room and you didn't really need it because you can do it yourself. Okay, minus 6b minus b equals 0. All right. Well, now we see that b can be eliminated pretty easily. In these 3 equations. So equation 1 plus equation 2 gives us what? A and negative 7a is negative 6a. B and negative b is 0. 5c and 5c is 10c. Well, that was easy. Now, eliminating b in this equation Well, we're going to take 6 times this equation, so we'll have a 6b and a negative 6b. So that's going to be 6 times equation 1 plus equation 3. Okay. Well, 6 times equation 1 gives us 6a, added to the 12a gives us 18a. 6b added to negative 6b gives us 0. As it had better because we're eliminating b. And 6 times 5c is 30c. Add that to 20c, we got 50c equals 0. And then I've got to be careful. I added equation 1 to equation 2. And so many of these equations have zeros on the right-hand side. And I wrote 0 here out of habit. It's a bad habit. Should look, 6 times, or adding this to this, so the b's go away. 0 plus 1, as we know, is 1, not 0. So thank you for correcting me. Okay, so now we have just a simple equation and 2 unknowns. So we take these 2 equations and we add 3 times equation 1 to equation 2. 3 times negative 6a is negative 18a, add the 18a, a goes away. And then 3 times equation 1, here will give us 30c, added to the 50c, we get 80c. And then 3 times the first equation gives us a 3 here, and the second equation has a 0, so 80c equals 3. So now c equals 3 over 80. I can take this and plug it into either of these equations and get a. So yeah, I will go ahead and do that. It won't take too long. Get a little complicated drawing arrows here, but let's plug this number in here. I get the equation negative 6a plus 10c, but c is 3 over 80 equals 1. 6 looks too much like a c. Okay, so negative 6a plus 30 over 80, which is 3/8 equals 1. I multiply both sides by 8 to get rid of the denominator, to clear the denominator. I get negative 48a plus 3 equals 8. And don't have room to write it. You can do the rest. Subtract 3 from both sides. You get 5. Divide by negative 48. We see that a equals negative 48. Negative 5 over 48. Now the process is really pretty simple, but you see that fractions are starting to get big denominators, so it's going to get a little bit messy. But we can now take our values of c and a and plug into any one of these equations. Well, probably easiest to plug into the first, but I help we do. There could be advantages of plugging in here because 12a would be 12 times 5 over 48. 5 over 48 is 1/4 and stuff. But we're not going to mess with that. So now we know that a equals negative 5 over 48 and b equals, c equals 3/80. So we plug this into the first equation, which gives us -5/48 plus b plus 5 times 3/80 equals 0. Now we could get a common denominator here. And multiply by that. We don't want to really multiply by 48 times 80. But the prime factorization, well, this factors into 8 times 10. This is 8 times 6. And 10 and 6 have common denominator. It'd be 5, 3. So an easy common denominator would be, geez, I'm gonna have to work this out. It's late in the day, sorry. 48 is 2 times 2 times, that's a 24, well, 2 times 2 times 3, 80 equals 2 times 2 times 2 times 2 times 5. So your common denominator is just going to be 3 times 80, which is 240, 5 times 48, which is 240. I'm not working through the details of that. We've done this. Using the prime factorizations, your common denominator, well, that's the common denominators, then got to have all these 2's in it. It's also got to have a 3 and a 5. That's the least common denominator. It has every factor of either of these and no extras. Okay. So multiply this by, well, multiply both of these by 240. You get this. Now, 5 times 3/80, I wrote is 15/40. So that each of these is just improper fraction. And I get 48 goes into 245 times 5 times -5, -25, plus 240v. And then it's going to be plus 45 equals 0. And then 240b equals 20. B is 20/240, which is 1/12. So this fraction isn't too awfully bad. Now, I can then plug A, B, and C. Sorry, I've got A, B. Yeah, I've got A, B, and C into the first equation. Well, I've only got A and C here, so I can easily solve for D. Don't have any more board space. So I'm just going to kind of write it up here small. Plugging in. Don't walk in front of the camera, though. Your anonymity would be shot. And behave while you're back there.
Okay.
Okay. Don't talk. You could be identified.
Okay.
You get FBI be after us and everything.
Oh, no.
You're still talking. You're laughing. Okay. Anyhow, a great former student just walked in, so gotta enjoy talking to him in a minute. Okay, but we're gonna finish this. All right. You turn around, look at the door, you never know what might be lurking. One day it was my wife, whom I just met.
Oh, my.
Yeah, she wasn't my wife at the time. So it can be scary looking at that door. Okay, well, back to this. Plugging A, B, and C in here and hoping that we got it right. A is 5/48. C is 3/80. Plus B equals 0. Okay, we still got that. Denominator is 48 and 80. So we're going to multiply both sides by 240. When we do, we're going to end up with 25 here. We're going to end up with 9 here. That's 34. And we're going to end up with 240D. So D is negative 34 over 240. I think, and I hope. So we finally get, I don't know where to write it. Okay. Is negative 34 over 240 equals negative 17 over 120. And that's a whole lot better. So now we have all the numbers here, and now we can plug those numbers back in up here, and we have our partial fraction decomposition. So this equals, if I've done it right, and that's unlikely, negative 17 over 120A plus B, which was, what in the world is it? We're at 112 over x squared plus x plus 4 plus C over x minus 3, and C was 3 over 180. So I'm going to do that 3 over 80, not 3 over 180. And then we have D over x plus 2, and D was, wait a minute. I used B instead of A. A was negative 5 over 48. So for the 12th time, I've dodged a possible error. At least we got to look for the ones I didn't dodge. Okay, and then we got B over x plus 2. Being careful, find D. Here it is. Here's a negative 17. And having dodged another arrow, noticing I've got a couple of x plus 2s here. This one should have been an x minus 3. And now there's still a little bit of work to do. You got to use common denominators and stuff and simplify the partial fractions. And I'm not going to bore you with that, because nobody's going to go through all that anyway. Okay. Now I did that to illustrate just how neat simultaneous equations can be, and how complicated partial fractions can get. When you get to this stage, if you understand partial fractions, if you can set them up, once having set it up, you're going to use technology. You might even get the simultaneous equations, but at that point, you're going to use other methods, matrix methods, whatever, or just black magic, which is most of what you find on the internet, because it's just a pre-calculus course. Okay, very good. So, best wishes. Remember that, just to repeat once more, if anybody happens to watch this, you have a list of 104 problems, 104 randomly generated problems. Every possible randomly generated problem that can occur on the test, on the exam. Now, the problems will have different statements, maybe in different words, sometimes in different numbers, but they'll still be essentially the same problems. So if you just memorize the solution to all those 104 problems, it's not going to be good. Okay, first place, you're nuts if you memorize that much. And in the second place, you probably can't memorize that much. Okay. You also have this, which is two versions of a final exam as it will be generated. These are two versions out of, well, I don't know, I generated maybe 10,000 of them. And some of those will be randomly placed in the Learning Lab Testing Center. And the test will be available all week next week in the Testing Center. Just get it done by the end of the week. I'll grade it. You get your final grade. Okay. So see you Thursday. Oh yeah, and on Thursday, what I've asked again is prioritize the 10 problems on this list that you would most like to see me work. Now that's going to be more problems than I can probably work in an hour, but it'll give me an idea of what you need for review. I'll probably make some other additional videos that nobody will watch to prepare for. Okay. And then you might consider watching them if you think they might be useful. So again, prioritize lists of 10 problems. And don't pick the same type of problem twice. You know, if it's a factor this quadratic, factor that quadratic, unless there's some big difference in those two quadratics, I'm probably not going to do both of them, even if they're first and second priority. Okay. Now, if one of them factors, the other one doesn't. I might do them both quickly. Okay, very good. I'll see you for the last class on Thursday.